I'm Brian Hawkins. I'm a staff engineer at Proofpoint, and I created KairosDB. And so this is me at KairosDB and inserting 1 million metrics per second into Cassandra. So it's kind of two parts. But first, I'd like to thank the KairosDB community. I've had a lot of support. It's been awesome. A lot of commits, a lot of help with the project. I wouldn't be where it is today without them. And thanks to Percona for supporting this and inviting me out here, and it's been great. So this presentation is going to be split into two parts. I'm going to do an introduction to KairosDB, talk about what it can and cannot do, and then the second part, I'm going to go into the challenges I faced as I was trying to cram a whole bunch of data into Cassandra, and it's kind of just what I experienced, trying to put as much data as I could into the smallest Cassandra cluster as I could. There was some interesting things I learned along the way. So first of all, KairosDB, it was, when I first created it, the only thing that was really out at the time, is 4 years ago, some odd, was OpenTSDB. And so it was heavily inspired by OpenTSDB. And I got to give that project a lot of credit, because there were some pretty cool, groundbreaking things that were done there in that for time series, just the concept of tagging and the way things were done in OpenTSDB. But I felt like I could do better on Cassandra than HBase. I was biased, didn't like HBase. So it's written on top of Cassandra as the primary backend. But KairosDB is very, very pluggable. You can, when I developed it, I made sure that just about any part of it could be plugged and swapped out. The backend is pluggable. If you download it off the internet, you're going to get, there's an H2 data store that comes on it. So you can just download it and run it on your laptop with any Cassandra in the back end. You can test it. You can do unit tests against it. And just recently, I found that somebody had done a GridDB backend for it, which is kind of cool. Just this last week, that came up. Like I say, very pluggable. And it scales really, really well. It scales with Cassandra. The Kairos nodes don't have any state on them. You can scale them out horizontally as to whatever your needs are. So this number here, 400 billion data points a month, is currently what we're ingesting at Proofpoint from the metrics that we're gathering. We're gathering system metrics and application metrics from hundreds of machines that we have in our production networks. And Kairos can save you money. How do you save you money? Well, we'll talk about that in just a second. So let's talk about using KairosDB, inserting data. And because it's kind of confusing, because all the time series systems that have come out, what does it mean? What's a metric? What's these different things? They all kind of have the same terms, or they use different terms. So this is, according to KairosDB, this is how we define things. A metric name, it's your CPU, your load, your number of requests, HTTP requests. That's a metric. And then we have tags that go with that, or some people call it dimensions of your metric. And these are things like your host, because you might have the same metric being reported from multiple hosts, and so you tag it with the host or the data center, or maybe it's a customer ID is one of your tags. So we just call them tags. So when you insert data, this is what your data comprises, is made up of. Your tags, then there's a timestamp, milliseconds since the epoch, or if you want to be before the epoch, you could do a negative timestamp and it'll go before the epoch, doesn't matter. And then a value, and the value is supported out of the box as a long, a double, a string, and then whatever data type you want to add in there, because it's you can add a plugin that just tells Kairos how to transform the data from JSON into a byte buffer, and you can add whatever data type you want and plug it in, and it will store it and move on. So how does this save money? So it was interesting that just recently at Proofpoint, we were looking at outsourcing our metrics gathering, and just to see, okay, can we do it for cheaper? Could somebody else do it for cheaper than what we're doing it for in-house? We have a couple engineers that maintain the systems, a couple clusters, probably 40 Cassandra nodes in a couple of different clusters and whatnot. So we're just looking at, okay, can we outsource this and be cheaper? When you look at outsourcing metric gathering, a lot of it comes down to, well, what's their pricing structure? What do they price this on? And a lot of them will be, it's on a metric. And the definition of that metric. And what we found was a lot of them your metric to them is the metric name and some unique set of tags. So if you have 2 hosts reporting CPU, and there's 2 tags for each host, well, that's 2 metrics according to them. And so that's how they'll charge it on some. I'm kind of generalizing, but that's what we ran into. And so is interesting to find out is we said, well, now we need to figure out just how many metrics we have according to that definition in our system. So I wrote a plugin for Kairos that would listen to these tag combinations, look for these tag combinations, and start writing them out to a file so that we could just figure out how much we have. And I started watching for just like 5 days, and we had over 2 billion metrics. And so far, we haven't found a pricing structure of any company that's going to like not want half of what our company makes to store their metrics in their system. Excuse me. So, but it's interesting. Metrics, when you start gathering this data, it's almost like a drug. And I'm going to think KairosDB is kind of like the drug pusher because it allows you to just take more and more and more. But we found in our company that, you get engineers start hooking on metrics, and they're like, hey, that's really cool. I can now monitor and just get an idea of what's going on in my entire company and across all my systems with just a single dashboard. It's very, very powerful. And, just to go to show the number of metrics we have, engineers start instrumenting their code, and we get more metrics coming from applications and whatnot into our system. It's huge, but it's just not something we can outsource. We do it in-house. So it can save you money if you want to do that. So how do you push metrics into to KairosDB? Our primary method for doing that is through CollectD. The development on CollectD has really come a long way in just the last couple of years, partly because of the explosion of time series databases. CollectD has plugins now for just about everything you want to monitor. Your file system, databases, MySQL, whatever, they've got plugins to CollectD, and it's a nice little platform for hooking into. So there's a KairosDB plugin. It's a Python plugin that lets you send your metrics off to your KairosDB cluster. And there's a little formatter. If who's here familiar with CollectD? Let's use it a little bit. Well, yeah, if you've used it, they've designed CollectD was originally, we're putting data really into Graphite. And it didn't have the concept of tags. It was just a name, and it was usually some hierarchical name. Here's a metric, and it would have like CPU, and then the core number, and some, this kind of string of data. Well, one of the nice things about the CollectD plugin for Kairos is that you can send that through a formatter and strip those things out and make them into tags. For example, like CPU, one of the parts will be like the core of the metric that you can pull it off, and so we have a formatter that you can pull that off and make that into a tag, and then you can look at all of the CPUs across the machine, or you can look at just individual cores and kind of divide it up in that way. It's pretty cool. But there's also plugins there's a Carbon plugin for Kairos to read Carbon data. There's a Kafka Reader plugin. You can tell it what topic you want it to read from, and then you give it a method to transform your data. Because if your data is in like a protobuf, you'll need to convert it and then turn it into a data point, and then it'll ingest it. There's RabbitMQ Reader, the Riemann Protocol Reader. Fullerite it's a metrics collection kind of platform, and they have native built-in support for Kairos. And then there's a truckload of client libraries that you can send data to Kairos. It's a REST endpoint API. You can send your data into it. Okay. Upcoming features. We're right now in the midst of doing a CQL conversion. Well, I am. And that's kind of, I'm going to get into that in the second part of the little discussion. We're also doing multi-cluster support. And this one has come about from some needs of different people. And the idea here is, well, with any time series data, your most active data, at least in our use cases, is probably like the last day's worth of data. Because that's the data that you're writing to it, and you're also querying it a lot if you're looking at doing monitoring, you're querying that last day's worth of data to figure out what's going on. And so the challenge with a Cassandra cluster is you scale a Cassandra cluster for two reasons. One is your compute capacity. You want to increase your compute capacity, or you want to increase your disk space in the cluster. Well, if you've got this time series data that's growing, you're going to need to increase your disk capacity, but you don't necessarily need the extra CPU. You just need someplace to store all this junk, right? Because some guy in your company says, I want to go back and query the data for the last 2 years. Okay, fine, let's keep it. But you don't want to make a 50-node Cassandra cluster just to store this, because you don't need all that CPU capacity. So the thought here behind this feature is, at some point in time, you tell KairosDB, hey, or you start up a new cluster, and then you tell KairosDB, here's my new write cluster, and this other one, the old one, is now just a read cluster. So all your new data is going to the new cluster, and your old cluster is just for read-only data. And Kairos will then do queries. It queries both, but when it writes, it just writes to the one. The nice thing about this feature is then that old cluster, you could then shrink it. You can consolidate your disk space or move it in so you have larger disk space but fewer nodes, and you can get rid of them, some of them. Or you could repurpose those nodes into the new cluster that's handling all of your compute and processing and queries on your more active data. And you can cycle those out. And then the other advantage of this is you want to do a Cassandra upgrade. Well, just start up a new cluster with a newer version of Cassandra, switch over to it, and then as the old cluster becomes less active because it's got older data in it, you can then upgrade that cluster or shrink it or just get rid of it. And after time, you can age out the cluster and just dump your data completely if you want to. Anyway, I think it's kind of a cool feature. But anyway. We're also looking at some enhanced tag selection and possibly even a big table backend for KairosDB. Yeah, go ahead. Yes, it's currently using Thrift. Yeah, and go ahead and just ask a question anytime. I don't really care. I'm not, although I forgot to start my stopwatch on, so now I have no idea how long I've got to go. Okay. So wait, I started at 4:50? Okay, I'm good. Okay, yeah, so now let's talk about the challenge I face. So yes, I originally wrote it in Thrift, and lots of reasons. The biggest one is that I was really hesitant about the validity of CQL. I still am. I do not like the language. I think it was the worst thing they ever did to Cassandra. That's just a personal opinion. Anyway, so I originally wrote it in Thrift, and I needed to convert it to CQL because they're deprecating Thrift, and there are some features in CQL that I do like. Querying data specifically was much harder to do in Thrift than CQL. CQL provides some cool features to doing that. So I've got to convert this thing to CQL. But in doing so, I didn't want to introduce some slowness to make sure that I keep the performance up. So what I did is I set up a test cluster, and this is just in my house. I had some little commodity machines I'd purchased. And they're 3 nodes, 3-node Cassandra cluster, replication factor of 1. They're i5, 4-core, 16 gigs of RAM, SSD drive. So that's my Cassandra cluster. And I started out writing. Well, I started out looking at the documentation. Okay, what do they recommend how to push data into Cassandra? And the documentation says, well, you insert one data point at a time, or one insert at a time. Don't batch it, because batching causes the data to then go from the coordinator and it has to split out and go everywhere. So just put it one at a time. Okay, fine, I'll do that. So I did that, and it sucked. I mean, it was so horrible. I was about to give up on CQL completely right at that point. I had high CPU, the high network traffic, low throughput. It was horrible. So I kept going. So against the better judgment of the documentation, I started using batches. Like, I've got to do some batching here, right? And so I switched to the CQL unlogged batch statement, and I found that my kind of sweet spot for my batches were at about 10,000. But that really depends on your data. In my case, KairosDB data is pretty small, and so 10,000 was just about right for what I was trying to push through. But there was the caveat to that is you have to go and modify your Cassandra YAML because they set these thresholds really, really low because they don't want you to send batches through the system. And so you have to go and modify these two options. And actually, I was going to do this slide again. I'd change this because 70 is way too low. And in my case, it's because I modified my code to handle batches too large. If I get an exception back, I just divide the batch up and I send it off in smaller chunks to retry it. Because sometimes I might get some data that comes in that's a little extra big. I would set that warn threshold at 149. Otherwise, you're going to have potentially just fill up your log files full of stupid warning messages that says, oh, your batch was too big, your batch was too big, your batch, who cares? I don't care. Like my code will handle it, so I should just change that. But anyway, so okay, I did this. Okay, it still sucked, but it had like a strawberry flavoring to it, so it didn't suck quite so bad. It was a little bit better. I still had a lot of network traffic. I was like, this it's better, but not great. Surprisingly, the compression wasn't on by default in my product. I didn't even think about it. It was like, oh, okay, I have to actually turn this on manually. So I modified the code. You add LZ4 compression, and this dramatically changed my network traffic. It was great. I mean, it dropped below the levels of what Thrift was sending the data at. And it had very little effect on the CPU, which I was quite pleased with. This is great. And also, I didn't put on the slide, but I also turned on compression between nodes, the Cassandra nodes. So as they talk to each other, they compress the data. That helped as well. All right. The other thing that I ran into was the native transport threads. As I was pushing data, my cluster was like only 50% utilized. And I'm just got so many threads. I'm trying as much as I can towards the cluster, and I start getting like node timeouts and all this other junk. But I'm like, the cluster's not doing anything. So what I noticed was that this setting for the native protocol, which is CQL, was set at 128, and when under the Thrift settings, this was set at like 2,000. So I was like, that's odd. So I kicked this up, and I was able to handle much more traffic in my Cassandra nodes than I was before. So it was bottlenecking me in the number of connection threads that I could hit the server with. Great, huge difference. But there was one little thing that was still kind of bugging me, and it was that crosstalk. I call it crosstalk between batches. It's kind of like what I was saying before. You send a batch to a coordinator node, and the coordinator node then has to divide it up. And so some fraction of it will actually go to that node, and then the rest of it gets divided up and sent to the rest of the cluster to where it needs to go. And I thought, oh, it'd be really cool if I could just batch it according to its destination. And I thought, oh, this isn't going to work because I'm going to get into the code and they're probably got some buried somewhere in the client. It's going to be horrible. But what I found out was that when in your code, in the Java code, when you build a cluster object that represents your Cassandra cluster, and one of the parameters you pass to it is your load balancing policy. You create a load balancing policy object. What I found is if I instantiated that outside and kept a reference to it and then pass it in, it gets initialized inside of the construction of your cluster object, but then I could use that object later and call it with a statement. So as soon as I got a CQL statement, I could call into it and say, hey, where is this guy going to go? And it would hand me back a list of nodes that it was supposed to go to. And then I had my key, and I could map this and group it by destination and send it in that way. And finally, it was like, there was much rejoicing. With all these modifications, I was able to push 1 million metrics a second into a Cassandra cluster, 3-node Cassandra cluster. It was that same cluster I had before, and I was maxing it out. But I had to use 2 Kairos agents clients pushing data at it. Now, I wouldn't recommend doing this in a production environment. This isn't your default set to scale out your Cassandra cluster. It kind of felt like driving a go-kart down Mount St. Helens, crap was starting to fall off, and I'm like, I pulled it, banded it together, But it did work. It worked for a few minutes, and then it started to fall apart. But anyways, it was an interesting experience trying to optimize that much throughput into Cassandra. There was, in the end, one little bit that bugged me that I just didn't have time to get into and figure out what was going wrong. But I instrumented all my code, and I had collect D, and I was watching everything, all these metrics off this cluster and putting it into a different Kairos node to watch the data. And I had two metrics that I reported. One of them was I was timing how long it would take to send the data to the client. And there was another timing, a metric that you could get out of the DataStax driver of how long it takes to send data to the server. And what I found was, and what was interesting too, is when I was sending data to the driver, I was using their asynchronous call, which is supposed to just hand it off and then return to me, right? But what I found is I was adding more threads and trying to push the data further. The time to call that method into the driver was taking longer and longer, but the time to send the data to the server wasn't. And I was like, there's something in the code that's blocking me before it's sending it off to the server. So that's why I ended up having to use two Kairos nodes to shove the data in, because something on the one node was preventing me from pushing data harder into it. But it's something that I'm going to have to take a look at later. Didn't have enough time to get into it. But if you're looking at writing stuff for Cassandra client, anyway, be aware of that. It was kind of interesting. So with that, blam, bunch of information. Questions about anything? I don't care, whatever. About my shirt, it's cool, right? KairosDB? So can KairosDB plug into my... Yeah, it could. It could. I mean, I've got like the H2 database that I run in memory. I mean, I have a table schema and everything that I've laid out to write time series data. It's horrible, but it works because it's mimicking my features that I get from Cassandra. It's probably not the best way to put data into MySQL, but you could. I mean, if you came up with a good schema for MySQL to put time series in, and like I say, I haven't put that much thought into it, you could. The Kairos, you can make a plugin that just implements the interface, and you can write your data to whatever you want. So it's totally possible. Other question, there was one right there. Go ahead. Yeah. Oh, yes. So querying, thank you. I did some testing with querying, although I haven't done as much because I did some initial testing up front, and I found that querying was about 20% faster than my thrift code. But as I was prepping for this talk, I actually realized I've done a lot of modifications or optimizations that will probably affect my query performance as well. And I haven't gone back and revisited those numbers, but I'm willing to bet I might get better performance now than I did when I first tested it, just because of the additional connections and whatnot that I've done. One of the things that KairosDB, it puts your data, every metric and set of tags ends up going into a different partition in Cassandra. And so when I send the queries out, I query for each partition individually. And with CQL, it lets you kind of span those queries out and have them come back asynchronously. So it's really quite effective doing that. Thrift was horrible at doing that. So I think I can get a lot better performance with CQL, little optimizations on it. But anyway, any other questions? Quick? Yep. Yeah. Oh, yes, thank you. Thanks for telling me. I totally blew that one off. But yes, so there's a Grafana plugin, and it just talks the REST protocol to Kairos. And so you can and that's what we do at Proofpoint for all of our front ends. We use Grafana. It's a great product. I mean, it's awesome. But yeah, this plugin just talks REST to Kairos. Yes. Yeah, we'll put Kairos behind. We've gotten to the point where we actually have some Kairos nodes that are dedicated to writes and some that are dedicated to reads. And they put them behind a load balancer, and so Grafana just picks one and hits it and pulls the data from it. Okay, I gotta cut it off because this guy's up. Thank you.